Hello and welcome to the presentation Connectivity and Data Management using the example of the DEPRAG AST12 production line. Let me introduce myself. My name is Martin Solfrank and I work at DEPRAG Amberg in the department Software Development for the Automation sector. My main role is the creation of the software for our special machines, primarily for the controllers of the DEPRAG DPU family, as well as Siemens, Simatic and Bradley Logix 5000. We also oversee vision systems. First, let's turn to the ERP and MES systems. The automation pyramid will be familiar to you. On the bottom level, sensors, actuators and drives are categorized under the field level. Here you will generally also find our screwdriving technology, which is AST12, etc. Above this is the control level. Normally the programmable logic control PLC and the DEPRAG processing unit DPU. Above the PLC is the supervisory level. The tasks for this level are supervisory control and data acquisition. Above this is the manufacturing execution systems MES, covering production and machine data acquisition and interlocking of process steps in real time. At the highest level sits Enterprise Resource Planning ERP. Changes to the automation pyramid. Changes are occurring particularly as a result of Industry 4.0, which also changed the automation pyramid. The top 3 levels of the automation pyramid have or will disappear in the future. These are largely replaced by cloud-based systems. Cloud services can also be installed in private or company internal clouds and do not necessarily require public cloud. Data transmission can be done via OPC UA or other protocols. Application in the AST12 production line. The classic automation pyramid is therefore not in use. Various communication channels are used between the stations and the ERP systems, and in between different stations. The details will follow later. The DPU is connected to the AST12 as well as the ERP system. The AST12 is also connected to the DEPRAG cockpit. The Enterprise Resource Planning ERP. The ERP is the integrated management system of main business processes, often in real time and mediated by software technology. These systems are responsible for the following tasks: business resources, material requirement planning, manufacturing resources planning, status of business commitments, for example orders, purchase orders, payroll. The following are major vendors of ERP systems: SAP, which is used at DEPRAG, Oracle, Sage, and Infor. Manufacturing Execution Systems MES. MES are computerized systems used in manufacturing to track and document the transformation of raw materials to finished goods. The following tasks are undertaken by MES systems: process control, traceability, operational and machine data acquisition, downtime analysis. MES vendors: iTAG Software AG. This is used by many DEPRAG customers in automotive and electronic production. Orbis, Systema. And many customers are using their own MES system. Finally, it is worth saying that there are usually no standard preparations, and customer or system-specific software must be created. However, this is not a problem as everything can be created in-house by DEPRAG. SCADA, PLC and field level. Supervisory control and data acquisition systems, SCADA, are often integrated in MES systems and or machine visualizations. SCADA is the first compression stage to transfer data to ERP or MES. Programmable Logic Control Systems PLC control the operation of machines and are equipped with HMI. for example the DEPRAG DPU210. The field level. At the field level there are sensors, valves, servo motors and screwdrivers. Many of these devices at field level can directly transmit data into the cloud. However, to reliably control complex machine sequences in real time and collate data across processes and pass this onto a MES system, PLC controllers such as the DPU210 are still required. The AST12 production line. The AST12 production line shares the same requirements which our customers face in their own production lines. For this reason, it can be used as an sample. For example, our e-automotive customers. It can be presented and demonstrated as a model. Particular importance is placed on the following requirements for the equipment: user guidance, 100% processing control, interlocking between the stations, full integration in MES and ERP. The entire project planning, design, assembly and software is realized in-house by DEPRAG. DEPRAG is your specialist and expert partner for the whole project. The assembly of the AST12 is divided into 4 stations. These each contain a DPU210 controller and a PKP position control system for 2 tools. 2 AST12 systems are attached to the PKP. The product is placed on a workpiece carrier VPC, which is manually pushed through the stations. The workpiece carrier is positioned and fixed with stoppers and lifters. The HMI and the pick-to-light system guarantee operator guidance. The screws are supplied through screw feeders and screw presenters. The following assembly steps are carried out. Station A, placement of the housing as well as assembly of the I/O and CPU boards. Station B, installation and assembly of the connectors. Station C, assembly of the power unit. Station D, connection of all cables and assembly of the rear housing. Station E is the test station, the end-of-line test. It consists of a DPU210 and an interface box for the inputs and outputs, as well as all communication interfaces. On this, the AST12 is connected. A testing and realignment device which simulates a screwdriver is connected to the AST12. From this box, a precision measurement device takes readings. Further, there is a label printer to print the type label. The jobs at these stations are update to the current AST software level, test of all inputs and outputs, test of all interfaces, test of the USB ports, test of the beeper, test of the touch display, AST12 verification and realignment, creation and printing of the factory certificate, creation of the type label. Now let's go to the station A, where we get the order data from SAP. The order data will be retrieved from SAP into the DPU210. The operator will choose the order on the DPU screen. The order number will be sent to SAP. SAP provides the following data: the part number, the material text, the order quantity, as well as all reserved serial numbers from the ASTs. The DPU prepares the order data and stores it in an XML file on a virtual server. Then it calls up the necessary program and it is ready for the first product. Communication is established as follows. The DPU is connected to a middleware called OPC router by using OPC UA protocol. This talks to the SAP's own remote function call RFC. What is a middleware? Middleware is so-called intermediate software which runs in the background without GUI or if necessary on a server. Now let's go to the assembly of the product, which will then from station A up to station D. A workpiece carrier with a product is moved to the stopper. In station A, the VPC is empty and the housing must be placed into position. The operator has to scan the housing label of the product. This is set by the housing supplier and is unique. This also contains the part number, which is then compared. The DPU reads the cluster file of this product and checks the status and the station name. If the cluster file is not yet present, it is created in station A. The assembly of the process is activated. Operator guidance and position control is provided. Boards must be scanned before assembly. Variant and revision will be checked. All scanned data is collected from the DPU. Final values and screw curves are collected from the DPU as well. At the end of the cycle, the DPU adds all new data to the cluster file. At the end, each product has to pass the end-of-line test, which is station E. A VPC with a product is moved to the stopper. Then all cable connections are made by hand. The operator has to scan the housing label of the product. The DPU reads the cluster file of this product and checks the status and the station name. The test process is activated. All cables must be connected. Firmware update and all tests are carried out. Verification and realignment of the AST12 is full automatic. The factory certificate is created and printed. The type label is printed. It must be verified with the scanner manually. The factory certificate is transferred as a signed PDF file into the SAP system. At the end of the cycle, the DPU adds all new data into the cluster file. Serial numbers of all boards and all test data is stored in the SAP system. The new AST is released in SAP and can be accepted in the warehouse. Communication protocols and middleware. Let's now talk about OPC UA. OPC UA means Open Platform Communications, Unified Architecture. It is a standard of data exchange as a platform-independent, service-oriented architecture. The standard was created by the OPC Foundation. It is becoming more and more important in automation. It is working as a server-client architecture. The data transmission runs via Ethernet. We have it available as an optional software package for a DPU controller. For connection to the SAP, we use the middleware OPC router. It is a central communication platform to connect PLC to ERP systems, database servers, etc. It has an integrated OPC UA client. Individual connections and transfers can be created via user-friendly graphical configuration. The SAP RFC, remote function call, is called by the OPC router and is SAP's own protocol and interface. is for processing functions from a non-SAP system. For example, we use the SAP function bp.prot.getDetail to get all the order details. The data transmission works via Ethernet. Cluster file systems. In our case, the cluster file is in the XML format. It is a shared disk file system where we store the AST12 cluster files. All computers in the clusters can directly access data without a server. And just quickly, the XML file, Extensible Mockup Language, is a mockup language for displaying hierarchically structured data in the format of a text file. The file is readable by humans as well as machines. Summary: DEPRAG has a lot of unique selling points. The entire project can be managed for the customer. No need to involve third parties. Large product range in hardware and software, so we can offer optimal advice. All necessary interfaces available for individual components. After-sales service for the complete project via one contact. Thank you for your attention and enjoy the rest of the presentations.